Well, let's have a look at normalization in action. If we take our customers database, and in particular our TBL customers, we can have a look and see how normalized this particular table has already been. Let's close the field list. Now, if we look across, we can see that the name has already been normalized to some degree. We have it split down to title, first name, middle name, last name, and suffix. So I think that's enough of a breakdown. The phone potentially could be broken down to two fields, an international dialing code and the telephone number possibly, if that was useful to us. The address has already been broken down to a number of fields, two address lines, the city, the province, postal or zip code, country, region. So that's been quite normalized. And as we move along, there aren't any other fields that would benefit from being broken down any further. However, what we do have is the second reason for normalizing your data, and that is a lot of repeating values in the same column. And we can see them immediately. When you look at occupation, there's a lot of occupations repeated. A lot of people are professional. The same with education. A lot of people here are bachelors or high school. The same with gender. In fact, there's only two choices. F for female, M for male. Yearly income, there's only a set number of brackets. Marital status, they're full of repeating values. So all of these fields really ought to be broken down into a separate table with those values in, and then we use the IDs of those values in this table to link through. Now, as we've already explained, linking using numeric values is so much faster than trying to query text values. And we have a lot of repeating text values in here that would strive to pull and slow your queries down. So if, as an example, we take our yearly income and we want to normalize this particular column, the first step is to create a new table. So that's create, table in design. And then in here we need a number of columns, but not a great number. We need a yearly income ID, which we can set as auto number. So we can let Access create the number for us. We also need a yearly income label, which is going to be text, and short text is adequate of 255 characters. The YL ID is our primary key, so we select that and make that the primary key, either on the right click here, as you can see, or on the ribbon, primary key. Either way, you'll get the little key in the margin, and then I'm going to save my table as TBL yearly income. Notice the same naming conventions I've used all the way through, with the camel case prefix of TBL and then a Y in capital and an I in capital, just to make it slightly easier to read because we're not using spaces. Okay, and then I view the table. Now in this table goes all of the unique bands that we have for yearly income. So I need to check in the customers table. If I sort these, it should be in some rough kind of order. So there's my first band, 0 to 25,000. That needs to go in here. And you can see that's given the ID of 1. The next band, as I scroll down, you can see how many people are in each particular band. There's lots of them. So it could take quite a while to find the next band. An alternative is to go to the little drop down the filter, and I can see what the next band here is. It's 25,000 to 50,000. So let's remove everything except 25,000 to 50,000, and then I can copy that and paste that in as my second band. Back to the customers, change my little filter to the third band, allowing me to then copy and paste the third band in, and then the same for the fourth band. This way I know I'm not going to miss one of the band values as well. And then the last band option, which is greater than 100,000. So copy and then paste. So I have 5 different bands. So that's the first stage of my normalization here. Really, this ought to have been designed at the start of the database. We shouldn't really be normalizing down the line. But sometimes it happens. Sometimes you've built a database and it comes about that perhaps you think, I ought to normalize that column. Well, we can do that now. So these are my 5 bands. What I now need to do is replace these labels in my customers table with the correct ID. So greater than 100,000 is going to be 5. So the easiest way to do this, let's just widen that column, is to copy that and use the replace option, find what I've copied and replace it with 5 in the current field, and the whole field has to say greater than 100,000. Replace all. I won't be able to undo, but I don't want to. That's fine. So they're all replaced. Let's go for the 50,000 to 75,000. Again, we copy that band, replace. Notice how it's already put that in, but the ID number is not 5, it's 4. Replace all. A little pause because there's 5,500 of them to change. Yes. Close that. Change the filter to the next band, and what I've noticed is that I've made a mistake in that I've replaced the wrong band ID here. The band I replaced, 50,000 to 75,000, is actually band 3. So what I need to do is filter by 4 and then do a replace. So 4 to 3 is then replaced. So yes, I don't want to undo that. And then let's go back for the 75 to 100,000. Copy that, replace, and that is band 4. So replace all. Yes to not undo. I'm getting close to all of them there. 25,000 to 50,000. Let's just double check the ID on that. That's 2. So again, we can copy, replace, and replace that with 2. Replace all. As I've already mentioned, but I will mention it again, this is not ideal when you're wanting to normalize your database structure. This should be built into the design at the start point. But we can still carry on. So yes, and that will leave me with one band, which is the 0 to 25,000. So let's replace 0 to 25,000 with 1. Replace all. Yes. And then we check in our filters and find that we've got everything is now an ID or a blank. So having made the change from text values to numeric values, we've already reduced the memory size that is required here for storage, which will then speed up your query. We also need to change the yearly income column into a numeric data type. Instead of short text, we change that to a number. Save the field. It will say some data may be lost, but it won't because we've replaced all the text values with our numeric IDs. And then save those changes. Close both of the tables. That's just saving the layout because I widened that column, so that's fine. And then I need to link these two tables together. So in the relationships, I need to add in the customers table and the yearly income table and join them together using the YLID to link to the yearly income column and enforce referential integrity. So I'm only going to be able to put IDs into the customers table for bands that we've already created and therefore exist in our yearly income table. Create. And that gives us the relationship between the two tables that is then required for pulling out the correct label when you require it in a query or in a form or in a report. Now, obviously, you would need to go through this stage for every single column that you now wanted to normalize. So the marital status, the education, and the occupation column. So it's a long process, one that you have to be very careful of the steps that you carry out so that you don't break any of the data, as I nearly did. But once it's done, your database will then run a lot swifter in its querying of the data. So that's how to normalize once the database has already been created. Obviously, as stated, the ideal situation will be that you create the database in a normalized state in the first place.